Hi, welcome to this video. And in this video, I'm going to do a measurement of ferricyanide using square wave voltammetry on a sensi-all potentiostat. So in front of me, I have a sensi-all potentiostat. I have some of our 501 carbon electrodes. I also have a 5 millimolar ferricyanide solution, and I'm going to sort of show you square wave voltammetry is one of our kind of it's a good technique for doing analysis. You can use techniques like cyclic voltammetry for actually doing functionalization, but square wave voltammetry is a pretty sensitive technique. There's probably the optimum settings that one can use when doing square wave voltammetry, but I'm just going to start off with some pretty generic not options, but settings when I do this one. I'm going to start at minus 200 millivolts. I'm going to go to 600 millivolts. I'm going to do voltage steps of 5 millivolts. I'm going to put it on the 100 microamp current range. I'll do an amplitude of 25 millivolts, and I'll do a frequency of 25 hertz. So that's what I'm going to put into the software, and I'll basically do the experiment now. So in front of me, I've got a I've got a sensi-all potentiostat. I've got the software here. I'm just going to give this a name so I can find it. So I'll call it ferricyanide 3. So I'm using the sensi-all potentiostat. I've got that there. I'll take the I'm going to take the potassium ferricyanide, and I will put 50 microliters onto the electrode. Simple enough. I will go continue. So these were the settings that I was discussing in the in the software earlier on. Start voltage minus 200 millivolts, 600 millivolts. Stop voltage, voltage steps 5 millivolts. 5 millivolts. Current range 100 microamps. Amplitude 25 millivolts, and then the frequency will be 25 hertz. Okay, that's simple enough, and I will hit start measurement. So you get a real-time, let's say, signal. This will be the oxidation now of ferrocyanide to ferricyanide. Now the reason it does that is because we started off at minus 200 millivolts. So in fact, we were actually reducing ferri to ferrocyanide, and that's the reoxidation of it. And I like this experiment because it's actually nice and fast. I always say this, but make your experiments fast in electrochemistry, because if you're going to develop a real assay from this, then you don't want people hanging around. Nurses, doctors, environmentalists, water analysis technicians, food technologists, they do not want to be hanging around for your 1 millivolt per second kind of experiment. Alright, so it's finished anyway. It says upload complete. I will just go to the upload complete means the data's gone to a system called Djuli. I'll just have a quick look at the Djuli here. I'll just do a quick refresh on this. Right, so there it is, ferricyanide number 3. The data is now in the cloud, and we can have a look at all the forward scan, reverse scan, etc. So let me just show you what that data looks like. So there we go. We've got a nice oxidation peak, to be fair. This is really the oxidation of ferrocyanide to ferricyanide. Somebody was asking me the other day, what's that? So when you look at that square wave voltammogram, that's actually the difference between what we call the forward scan and the reverse scan. So I haven't not in any way talked about the theory tonight. I've only talked about essentially the settings to sort of get your first experiment going. But what I can do is I can just add a couple of things here. So I'm just going to look at the forward scan on that one. I'll look at the reverse scan on that one, and I'll close that, and we'll be able to see what's going on here. So I can see then that this signal C, which is what I call the difference, is actually the difference between the forward and the reverse. So in fact, now the reason then you get this sort of funny tail here is because when you look at the reverse is like, there's a signal here of like minus 80, and here it's 50, minus 50. So minus 50 minus 80 is actually 30. So that's why you've got this kind of trail here. But it doesn't matter, because you can just essentially kind of zoom in and not so much cut it out, but then you've got your nice ferricyanide peak there. So that was just a quick experiment, or not a quick, yeah, it was a quick experiment, just to kind of give you a sense of what the settings can look like when you're doing your first kind of experiment with a model system like 5 millimolar ferricyanide. If you have any questions, don't hesitate to reach out to us. Okay, thanks very much.